So you're able to see my screen, right?
Yeah.
Manoj, have we gone through the PPTs anytime? Because
No,
I couldn't.
no, we didn't go through the PPT actually.
Okay. So the questions which we were discussing the other day, right? It is covered in this PPT as well
Hmm.
on convolution, how the operation is happening and all. So if you see here, mainly what I could understand is there are three terminologies. One is the input image, the second is kernel filter or the feature detector, and the third one is the output, which is called the feature map.
Feature
So
map.
we will get an image, huh, which will be a matrix like if it is a 2D, it will have the 6 by 6. The structure will be like how the matrix is organized. And if it is a 3D where RGB images are there, you will get three images of three set of matrix.
Hmm.
And based on that, whatever filter we are getting, based on that, we are trying to extract this map. So you will have the complete input. In from there, we will be extracting the feature map, and that size will depend upon the final size will depend upon the filter and stride.
Hmm. Okay. Filters, right. Then there is something max pooling also, right?
That is the next layer. The first will be the convolution, right?
Hmm.
In the convolution, we have. Okay, let me go back to the this one. So you will have the input image, then the convolution, then pooling, then you will have the fully connected layer.
Convolution generally we will identify the different feature, right?
That's correct.
And pooling, max pooling or mean pooling, that actually it is reducing the size of the feature, right?
So convolution will do the first level of reduction, then pooling will find the max or average or whatever logic we are using, right? Based on that, it will take one. If we are in there will be a pooling filter. Based on that filter, if we are using the max, it will take the max value. If we are using the average, it will take the average value.
But generally, what we are trying to do, see that mathematical I understood, but exactly what we are doing. Suppose out of 2 by 2 max pooling matrix, from if I apply means I will take the maximum value among the four value. That I understood. Minimum, average, max. Okay. But exactly what we are trying to do it after convolution image. When I am applying the max pooling means I am reducing. If you see the image, so many convolution image from that actually maximum clarity picture it is taking, or what exactly it is trying to do?
Correct. It's reducing the picture size but keeping all the features. From all these pictures, it will keep the features which we are looking for, but it will reduce the image size.
Instead of max, if I take the mean or average, that way, how exactly it will be different?
So if I go here, uh, can we cover this first?
Yeah, yeah, definitely.
Yeah.
Yeah.
So first it is convolution. Convolution, we have the input image and we have the filter. Let's consider only one filter for now. In this case, they have two filters. So each filter will create different feature maps. So here we are applying the first filter. So it's similar to once we have that filter, right, we will be multiplying and getting the value based on this filter. The filter will be first applied to the 3 by 3 part of the matrix and we'll get the output of it. So after multiplication, here we got the output as 3. Then based on stride, we will move to the next layer. If stride is 1, we will go to this is 1 by 3. So this is a 3 by 3 matrix. Then we will start from 2 to 4. So if you see here, the based on the stride, in this case, stride is 1. It's going 1 by 1. So
Yeah.
like this, it will cover all the edges. So if stride is 2, it will go directly to the third position. It will not take the second position. It will go to the third position. So keeping stride more, it will be faster to complete. But some cases we might miss some important features. So based on the picture size and all, right, we need to decide whether we should go with stride 1 or stride 2 or higher
But
strides.
in these cases, if I take stride 2, first suppose first 3 I have taken filter size 3 by 3, first 3 I taken, then after 2 going means I cannot do the next. So only in each row only I can do only one uh, convolution, right?
It will do this one, then it will do this one.
No, but stride 2 if it is there means that time it will not come. It is in this case stride 1 that is okay. 2 times I can do.
No, stride 1, it will do column by column. It means it will skip one column, then it will go like this.
Yeah.
If it is stride 2, it will skip one column and then go to next. It will be first 3 by 3, then
Uh,
it will be from 3 to 5. This 3 by 5 portion it will do.
yeah. Okay, ठीक है, understand.
Once this convolution is done, then we will go to the polling part. Let me see whether this has the polling. Okay.
So Veena, this convolution
So
means using these filters and reducing the size, right?
using the filters and extracting the features. No, the correct terminology is extracting the features.
Okay, so it's there's
So
nothing
you
like MLP or something. MLP is not
multi-layer
there.
perceptron.
Yeah, we are not having that loss function and finding that parameters.
No, in this stage it's not there.
I mean, in CNS, do we have that or is it? No, I mean,
The
is it built on top of MLP or is it separate something?
so the hyperparameters you are asking, right? That we are applying at the last.
Mm-hmm. The weights and the loss functions and all. No? In the MLP, we have.
So okay, in the ML we have the classification, right? The normal classification process. There we have to apply everything from the start to extract the features, then the classification logic, everything we have to give. In DL, we are not giving anything, right? We are just specifying the layers. So for each of these convolution, there can be 3 layers. One is convolution layer where we will extract the features. Next is the polling layer. And third one will be the fully connected.
Yeah. So in the till midsum we were doing the DL, but there were also the same loss function. Everything was there, right? Only, but when we come
And
to the
the,
CNN, we don't have those things, right?
no, here also you are asking about the Adams like that, right? Those functions that we can still apply, but that is towards the end of this, we will apply all those.
Oh, okay. Okay.
Can I use something?
Sorry.
Can I add something?
Sunanda, you're trying to
something?
say
Need to explain what actually Manoj is telling. Like we will apply those things in the fully connected layer, the last layer where Veena has mentioned one file more. Can you go to the Veena?
This file.
Here you are having fully connected now. There we will be applying the DL concepts, right? Hello, am I audible?
Yeah, you are.
Telling like in this fully connected layer, we are applying this one DL concepts where we are going to initialize the weights, everything what DL concepts we have learned, like performance, the position, that and everything, right?
Are able to see this?
Yeah.
So these activation till here we will be applying the activation functions and all. So there in the compile we can apply all these.
Mm-hmm.
Yeah. That one comes in the fully connected layer, right?
Yes. And I think compile part comes into fully connected layer. Correct, Veena?
We are defining fully connected here, but what we are telling is this parameters will be used in the fully connected.
No, Ina, no, no, no. We are telling like we generally used to do this forward propagation, backward propagation, calculate the weights, all those things what we have learned previously that we are going to be doing in this fully connected layer.
That's correct.
Yeah, that was I was telling the same. He asked to know Manoj, where are we applying these concepts? I was answering to that question. Like in the fully connected part, we will be using those things. These max pooling, average pooling, convolution, everything comes prior to this thing, fully connected layer.
Okay, so the CNN comes first, and this all these things are coming in the end, right? So initially we
Only
have.
Uh,
convolution. Manoj, only convolution. Neural network again, then like it's a combination of. So
Mm.
neural not network is also we are using, but this in because of convolution actually we are doing all these stuff, extra things we are.
Okay, okay, fine. Let's go ahead. Yeah, yeah. Thank you. Yeah.
So going back to pooling, so pooling we have the max pooling and the average pooling, right? So what we are doing is we have the result of convolution here. On that result set, we will be doing the max pooling. So if you see here, it's a filter is 2 by 2 and stride is 2. So the first pooling, first filter will be applied on 2466. Then since it is stride 2, we are skipping the 4769 and going directly to 7498. So from 2466, we will take the max value if it is max pooling, average value if it is average pooling. So 2466, the 6 is max, hence we took 6 from this. And then we are going to 7498, the max value is 9, we are taking 9. Similarly for the other set. So if it was tried one, we will consider 2466, then 4769, 7498, like that it will go one by one.
Understood.
Yeah, yeah. It's clear. Yeah.
Yeah. Only one, just for clarification. Even that this is for dimensional reduction only we are doing, right?
That's correct.
But instead of max pooling, even average pooling or mean pooling do also that also dimensional reduction only it will happen. Then in that cases, what are the feature wise or any other cases? What is the impact difference from the max pooling?
So if you do the max pooling, what I understood is it keeps all the features. Whereas if you do the average, so uh, average pooling, there is a chance that all the features, because we are downgrading something, right? When we take the mean, it will not take the value completely. When we do the max, it will take the max value and keep it. Whereas if we take the average, it will reduce the value. There will be some features coming in, but this is downgrading that complete sample size.
That is in term of intensity or blurred picture will be if I take mean or if I take max mean in high intensity or some of the feature also we can skip. in that case.
Correct. So, correct. It some cases the features will be skipped. So I don't know anyone has seen a image of a dog, and once they do the cut the image and then keep it, it can become multiple. Means we can make multiple dog images based on if we cut and keep it separately. There was one picture coming in LinkedIn and all. Okay, let me check and I will share that with you. That will give the idea of the CNN.
But Veena, normally image matrix is zeros and ones. But here, some different number. So that is what quite confusing me.
No, no, this is just an example. No, let's. I mean, we will not go into that
No, no,
detail.
images pixel values can be vary from 0 to 256, something like that. Okay.
Yeah, the intensity values, right?
That
So
is
that
color.
yeah. So
That is color.
I
For
mean,
the grayscale also it will be 0 to 256, right? 255.
Yes, yes,
correct.
Yeah.
yes, yes. Correct.
There will be layers for the RGB, and then it has to be flattened.
And Veena, what is F over here? F.
Filter.
Okay, filter.
S
Filter
stands for stride.
Stride. Yeah, stride and filter. Okay, thank you.
stride. What is filter? Filter is size, right? 2 by 2 or something.
Correct.
So, what is an objective of max pooling? Sorry, I didn't understand that.
So that's where I find this cheat sheet useful. So you're able to see this, right? Do I need to increase a little?
Yes, Veena, it's visible.
Okay. So what they are telling is it's the same what we know. Each polling operation selects the maximum value of the current view, whereas average polling what it will take the average value. So max value when you select right, the intensity of the feature will be kept. It preserves the detected features. Whereas when we take the average, this like you are seeing the difference between these two images, right? So it will downsample the feature map.
Okay. Okay, so it records the most. I mean, the pixel whose intensity is maximum, right?
Correct. From each of the filter or sample which we are selecting based on filter, each of the cases it will keep the max value here. So the
Okay.
intensity will be max here, whereas here we will take the average of all the values, right? So that will
Guys, this is all filtering techniques. I mean, Max will mathematically. I mean, look at those filters as a mathematical filters. Uh, Max will take the max of the filter size, right? When applied to a particular patch. Average will take just the average. I mean, nothing more. I mean, intuitively, I mean, you can't even when in actual practice. I mean, you can't even see those images, right? I mean, intermediate images. So just look at it as a mathematical, uh, uh, I mean, filters. Don't look at that as, I mean, you really can't perceive how the images will look, right? After taking the max of a particular patch. Uh, I mean, it's good way of representation here in the cheat sheet, but then you really uh, can't see anything.
that's correct. Because this is just one filter they are applying.
Right. I mean, and the reduction of the images, it is achieved by that stride which you apply. Uh, so uh, what what the presentation here it is shown is, I think, the image getting reduced from I think 6 by 6 into 3 by 3 through that stride. I mean, it doesn't have anything related to the filter as such, right? I mean, there is a reduction due to the stride that you apply along with that filter.
What I understand is like when we are using max pooling, only the brighter values of the image are captured. Only the required features are captured. But when we are going with the average pooling, only the uh, shades that are required is getting captured. It may not be that exact as respect of max pool. So based on the application, we choose whether we need to apply max pool or average pool.
So
If we are particular with having some edges, uh, certain curves, some slants in the images, if you want to detect those things, then we go with the max pool. But when we are considering, if we go, if we are doing some editing things where we wanted to have the exact shade of that thing, if the shade, if you wanted to have the same exact shade and wanted to place it in some way, then we need to extract those shades. There, I believe like average pooling will come into the picture because it is not going to focus only one thing, one feature, whether it is a curve or whether it is a edge, something
yes,
like
yes.
that. I think someone can correct my understanding.
Yeah, even I think
I think we should not be commenting how the image looks, because I mean, edges and all those are very intuitive parts. I mean, we can just visualize those, but then I mean, in reality, what happens after training, you really don't know. Uh, so I
Yeah.
mean, uh,
Just
so we should not be
normal
worrying about
understanding,
all those.
more, yeah.
I mean, just understand the math behind it and move ahead. Otherwise, you'll get lost uh, most of the time.
Yeah. So you're okay with convolution and polling, right? Can we move to fully connected?
Yeah, please.
So before fully connected, right, we need to have a flattened step. So this, when we write the program also, first put the convolution, then max pooling, and then before fully connected, there should be a flatten operation which will convert this into a 1D array.
So flatten will always convert from a 2D to 1D, right? Not 3D to 1D.
2D to 1D, correct.
So can I construct like any n by n matrix as having only one column with many rows?
Yeah, that's what my understanding is.
Yeah, yeah.
And Veena, this is done using flatten something like that, right?
Flatten command. Go back to that program. We have a step before fully connected. We have one step to flatten it. And then we are doing the optimization here. So in case if we want to add any optimization algorithm and all, we can add it here.
What is the optimization algorithm?
So if you see here, we have added the Adam optimizer.
So can you just go up
Right.
a little?
In this.
Yeah. Yeah, just wait. See, we are adding a COM2D with 64 number of kernels of 3 by 3 with strides 1 by 1. So how do we come to this number 64, starting with the 64 and then 128?
This was given in the question paper.
And 64 is what is 64 is 3 by 3 is the kernel size, so 64 layers maybe, right?
Number of kernels here, right?
Correct. So we have 64 filters. The K
Filters,
value
okay.
is 64 here.
Yeah. So the image is of 3-dimensional of 227 by 227, right? That is 3-dimensional. That is RGB. So for that 227 by 227 with three dimensions, we have 64 kernels first. Why 64 kernels? If you have a filter of 3 by 3, if you stride a 3 by 3 filter on 227 by 227 images, so your image size will contract, right?
I think it's not mandatory that you put 64 kernels only. You can
That
put lesser
it's
or
for
more.
this question.
My question here: Can I have a filter of greater than the image size? That is 227 by 227, right? So can it be greater than 227?
Maybe you have to ask ChatGPT or
If the kernel size is greater than the image has to be padded in that case, and you have to say same uh, as
No,
the
he's
padding.
uh, asking number of filters.
Yeah.
What is it?
It's not the filter size, it's the number of filters here asking. He's asking. I think
What?
it is possible because we are using 512, right?
No, what is the question here? I mean, I did not understand.
What he's asking is in that program, instead of 64, can he use a number greater than 227?
Greater than 227. I mean, 64 is your output channels, number of channels, right? 227 is your input number of channels. So uh, you will have filter which is of size 3 by 3 into 227. That is the input channel size into output channel size. That is your total filter size. I mean, total weight matrix size, right? So you can have anything on the input channels and the output channels. It depends on the network design then.
For me, this program, right, when we put the 512, it is throwing me error telling memory issue.
What is the size here? 512. Sorry.
Yeah, sorry. Good.
We will calculate the size at each level. Let's start from the start. Can we go at the top? Yeah. So input is 227 by 227 by 3, right? Now 3 is your channels. 227 is your width and height, right?
Yeah, correct.
Now convolution happens with a stride of 1 by 1. What is the padding here? Padding is
It will be 0. They haven't given in.
given in. So this is TensorFlow, right? I think default mode of TensorFlow is same, right?
Mm.
Same is, I mean, the required padding is added to get the input equal to output size. So the output is 227 cross 227 cross 64 of the first convolution.
So this is the output size we are getting.
Okay, so no padding is added. Added. Okay, sure. Then I think it's the same. Not same. What was that? Actual.
What is the
Is a default mode. Okay. Can we
error?
check?
क्या आ रहा है?
On. Okay, valid is the default. Can I? I'm pasting one link. Open that.
Okay. Okay.
No, you share it. I'm just pasting one link. You just open that. Okay, go down. So yeah, no, on the API, the what little, yeah. So padding is, I mean, the valid is the default padding. So not the same. There are two types of paddings in TensorFlow. One is valid, one is same. When it is same, the default, I mean, the whatever the required number of pixels to be added, it adds by default. I mean, as padding. When it is valid, it doesn't add any padding. So in this case, going back to the problem,
They have given assume valid padding.
Yeah. So that is what. So that is why it is reducing to 225 cross 64 as the output size of the first convolution. Now the second convolution, again, stride is 1, right? So it will again give the output as 224 cross 224.
223.
No, go back to that. Oh, 223 by 223 by 128, right? And then max pooling with stride of 2 must be, right? So it is reducing it to half.
Yeah, they have given stride 1 in the question. But by default,
No,
what?
Where is max pooling? So 2 by 2. What is the stride? So this is wrong. I mean, how will it reduce to? The stride is 1. Then you have to mention it as 1 in the program also. Go to the program. Say stride as 1. Let me give you another link for this. Stride is equal to, what Mohammed Idris has said is right. It has to be that way.
And then I'm getting this error telling memory issue with strides.
When you say stride is one,
Let me change.
Why don't you run this program on Google Colab? I mean, there you will not face, it's not face memory issues.
Oh, okay.
how much is your RAM? I mean, it should not go.
Mine is 16, I believe.
Should be enough, I think, for this.
No,
16,
I used
I think.
Google.
You are using Colab, then you have to attach your data set also.
Someone needs to go on mute because the voice is echoing.
Voice is echoing, na?
Yes, voice is echoing. So somebody has to go on mute. I mean,
I think it's done now.
it's fine now. So I think probably it was from Bipin's end.
Yes, sorry guys. It was me.
No worries. We are on 2nd October holiday.
Yeah, also the
I
dry day.
used Google Colab with AI 100 GPU. Still, resources not sufficient to execute this code.
Yeah, I think some issue. It was showing message telling we need to reduce this fighter. In flattening,
So
we
you
are
can,
using fighter.
yeah, you can disable this. It's not for execution, right? It's only to write the answer. So disable the flattening. Comment out from flattening to report. Yeah.
Sorry, but what was the issue you were facing with Collab?
Collab, I didn't try. Understand.
The resource is not sufficient. Memory is exhausted.
Oh, drive storage request.
Dens, I think those were the number of neurons, right? In the dens.
Yeah, that is number of
5,
neurons. Yes.
55512 something. So it seems like it's huge.
Yes, yes.
Comment it out from dense. Yeah. So this you don't need to run those commands. No, you add this at the beginning
Slash star.
and then yeah, not slash three quotes. And at the end. No, at the end. Just before
You
activation.
don't want to. Okay. Okay.
Yeah, fully connected layers, disable fully connected layers. That is not executing. Yeah.
Any epoch? Okay. Total parameter C. And the size also.
This is the answer for our second question.
2172 217256. Is that?
So in max pooling also there is a concept of padding. So you see that 222, 223 has been reduced to 222. The sizes.
Um,
So it's taking that actual size, no padding.
No, it is not because of padding. It is because of stride is one.
No. If you add padding now, padding of 1, it will give you 223 itself.
Yeah,
You can
yeah. It will give
experiment that way.
223.
Yeah.
Yes.
So
No, you are correct. Yes.
just someone was asking, can we add it now?
you can always do that.
It's taking that value higher one.
Just that the parameter increases in the first.
Mhm.
One.
Any questions till now? What we have seen is filter is 3 by 3. This F by F is the filter size and C is the 64 was the channel. Is in the channel or
What is they are asking in the question?
in this question? They are
Yeah, like whatever
they have
we,
this one, right?
like whatever we are solving right now. So it's the C part, is it? Compute the output size after pool 2.
Correct. So these two
Okay.
yesterday we solved the actuation function we can just write. And this was the last question. Sorry. Compute the output. They will give the metrics and then we need to compute the output of this one using the input image size and filter is given. Based on that, we need to compute the output.
So output size will be like the shape in our model architecture, like when you have applied the pool 2. Okay, I think, or maybe this pool 2 is something like max pooling layer 2. Like in your architecture, maybe it's the second layer of max pooling or average pooling. Okay, so after that, what is the size of your shape? That's what it's asking, correct?
Hmm. So
Uh,
this
Okay, but question
yeah,
is that okay, this code. I mean, see that right now you have written everything on the Colab or Jupyter. You run it and you've seen this shape. But in the exam, we will not like. How will we get it? I mean, we will not have any code thing. Like we will not be able to execute to get the number of parameters. So how will we do it in the exam?
we need to use this formula.
Uh, okay, can you
We will
zoom a
have
little
the
bit?
Can you explain this numerical part?
Yeah. Actually, you're right. Even in our assignment, also use the formula to get the number of parameter. But since I had the output, I mean, since I had the output in front of me after running the code, so I could validate. But in the exam, okay, I guess we'll have to rely on the formula only to get the number of
correct,
size.
correct. input
Mm,
minus filter, padding
mm.
mostly it will be 0, by stride plus 1.
Yeah. Okay. 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 And this PDF is shared. Like, what is the name of this PDF?
It's
Uh,
yesterday it is shared in this meeting link only it will be there. When
okay. Okay.
What is
No,
this P
nice.
start and
So,
P end?
that is for the padding, mostly since it is valid padding rate, this value will be 0. So we don't have to consider the P start and P end. We can just go with I minus F by S plus 1.
mhm.
If they
Okay.
mention some
So it's
padding
like a
value,
cheat
then
code.
So instead of P start and P end rate, generally they will convert it into 2P because both side it's getting padded equally, right? So it will be 2P. So that's the final formula we can use.
exactly the same formula that we have discussed in the previous session.
Okay. Then maybe we can move it to the next question if it is discussed.
So in this, right, I found only that much this till this page. The other seems to be a little advanced. We don't have it for Yola and all. We don't have it in syllabus, right?
Yeah, YOLO is
Yeah.
not
They
there.
have. Yeah. They have not covered it. Yeah.
You, this is part of mask R CNN. So then YOLO, I think, comes into the picture.
But maybe we can use it for the thesis if anyone is interested to do the image recognition, then they can opt this for the final thesis.
Ah, yes, it's good if you want to recognize something. Uh, those, I have gone through multiple case studies where during COVID situation they have used this mask R CNN. So yes, it could be a good project.
Anything else we want to cover? So Deb, you have something, right?
Actually, after this completion, only we'll discuss that point. Some question. It is covered. Anything else to be discussed now?
I think Veena finished, right? Or what? Veena, is it complete or?
Yeah, in that the PDF, right? It's completed. If needed, we can go to the next questions.
Okay, fine. Yeah. Maybe Sudeep want to ask something, yeah, regarding the question.
Yeah, just I have some clarification. Regarding the previous March question paper, no? Can I share?
Yeah, yeah, sure.
Think if you can clarify this question as well as this question. What is the equation exactly? Input kernel, this thing is okay, but I minus, I think I minus kernel in a I plus 2 padding minus 3 minus 2 into 1. What is that equation is coming here? 2 dilated convolution. What exactly happens in 2 dilated convolution?
It
In
is
case of
7.
dilation, the input, for non-dilated, that is dilation is 1 by 1. So that is your input is not dilated. Dilated in the sense, if the you can visualize it this way, right? I mean, in stride, the output is dilated. I mean, the output is produced every second pixel of input, right? If the stride is 2, uh, uh, for dilation, it goes on the input. The filter is applied every alternate pixel. I mean, if the
Some noise is
Just
coming.
to, yeah, just to put it in a little bit simpler way, no? See, stride is in this, it's echoing. Right, you apply the kernel on top of input, right? So
Yeah,
and you calculate the values, right? And
yeah,
then
yeah,
you move one row or one column after
yeah.
that windowing windowing length. That the next calculation will happen after one row or one column. That is what stride is. But when we say dilation, when we apply the kernel itself, you have to apply it as a elongated one with the gap in between the rows and columns in the kernel.
No, let me just explain you. Suppose this kernel I am applying on top of this input image. First 3 by 3 I have taken. Up to this I have taken. Okay. After that, next if 2 dilated means 2 column gap I will give. Next I will start here. Here to here. This third, fourth, fifth I will take. Hello.
I thought you will start from column number 3 now.
That's right. Third, fourth, fifth next I will take. When after one gap, actually it will have go to the next, means that is how 2 is happening. So like this way, if it is like a 2 stride only it is happening then. No.
So guys, you are getting confused with stride and dilation. So
Yes.
understand this thing, right? I mean, stride is on the output side. I mean, with respect to the input, right? I mean, which where the filter has to be applied, stride tells that.
Yeah.
Okay. Uh, on the input. Now, dilation, what it tells is basically what values of the input has to be taken. I mean, is it consecutive values, or the if there is a stride greater than 1, sorry, the dilation greater than 1, uh, it will apply alternate pixels. I mean, it will leave that many pixels and apply it on the next pixel. So here in this case, the yellow boxes, right? As a dilation is 2. If it was 1, it would have taken 1.50, right? Because the dilation was 1. But in this case, it is dilation 2. So it is taking 1. It's leaving the next column and the next row, right? And going to the 0, again leaving one column, one row. So the filter is dilated in this case. Uh, that is uh, uh, it's it's just like expanding the filter with 0 rows and columns, and making it a bigger filter, right? You can visualize it that way.
Okay, but I am just first putting on top of the image my filter. Thereafter, I will just calculate one gap between these two dilated images. suppose -1, 0, -1 is there.
So,
So
so,
then
so if you observe here, the filter size on the input, I
hmm,
mean, when you overlay the filter on top of the input,
yeah,
it has reduced to 5 by 5 instead of 3 by 3 because of the dilation.
5 by 5.
So the filter, I mean, the yellow boxes has, I mean, yellow box, you can see it. It has increased to 5 by 5 instead of 3 by 3 with dilated filter. That is, your alternate rows and columns of the filter are zeros, and you can apply directly that filter. You can visualize it that way. Your filter is getting dilated in this.
But with stride while I will move my filter,
So
right?
don't mix this shade. I mean, this is just a filtering technique again. Uh, I mean, when you say dilated filter, it will introduce alternate zeros in row wise and column wise, and apply the filter. Right? Expand the filter first and make alternate. I mean, the expanded columns, that is, will be all zeros, and expanded rows will be all zeros, and apply that filter, right? I mean, 3 by 3 will look like a 5 by 5 now.
Then what is here stride one rule?
Sorry.
Stride one, what is the need here?
Stride is just the I mean, as I said, stride is on the output side, right? I mean, here, if the stride is 1, I mean, it will still produce you the all. I mean, if the padding was uh, same in the sense, there are two paddings, right? You remember again, to recap, same and actual, right? If the padding was same, it will pad appropriately and still produce the same size or as the input size. Output size will be the equal to input size. In case of dilation also, I mean, irrespective of uh, I mean, the stride still has the same effect, uh, irrespective of dilation. It,
Well,
it's only
if
the
the
filter values that are used. Uh, it's a bigger filter. Right?
see stride one concept. So Bipin, can you please be on mute because
Yes,
like
yes.
your voice is. Yeah. So try to see like when you use Python for loop, right? So in the Python for loop, you give let's say I equal to 0 and then some condition. And then there is one more parameter which is called stride, okay, which tells you that how many steps you need to skip. For by default, the stride value is 1, but you can also give the step size or the stride there as 2, 3, 4, okay, which tells you that how many times, like how many steps you'll have to skip uh, in order to do the next computation in the for loop. So the similar concept of applies here also in case of this CNN. Like you are giving a state value which can be a 1D or 2D value also. That will tell you that it how many steps you need to skip. I mean you need to move ahead. So that is the similar concept here. And dilation, like I've just gone through the geeks for geeks link. So they are like it's like filling filler values. I mean you are dilating the kernel size by inserting some values to make it larger. This much I understood, but I'm not sure about the dilation because I think covered in the lecture context sessions also. But
Yeah.
stride is I think pretty much same what I said.
Stride is okay, but the thing is that when I am moving one by one, suppose yes, stride equal to 1, on top of the image, a kernel I am putting, and thereafter one by one, suppose I am moving left to right, and after once the one row is completed, then slowly down one row I will again scroll left to right like this. I'll do it. That's okay. But when I put it my kernel on top of the image, then I have to perform diluted convolution. Two diluted convolution. Suppose my kernel value is -1 0 -1 0 4 0 -1 0 -1. When I am doing convolution with the my first 3 by 3 of my input 0.511, that value how just like normal my multiplication and addition I am doing, or here some arbitrary how it is 108 has come. That is what the doubt. Calculation how they are doing. Two diluted convolution. That only the thing. Value how they are.
I'm sharing for a minute. You're able to see the screen?
Yeah. Yes.
So this is the slide deck which we have got. So the filter, usually when we say there is a 3 by 3 kernel, we will apply it in this space. But when we have the dilation, we are making it into a higher one. So the coverage will be more. If you see this, I think here they have mentioned.
Coverage, even it is more with what is the calculation they are doing there.
So you are able to see the screen, right?
Yeah.
So for one dilated convolution, it is same as normal convolution. For two dilated convolution, skip one cell. The kernel size is still 3 by 3. However, it can have 7 by 7 receptive fields. So if it is a 3 by 3 filter, they are taking this formula. And if it is a 4 dilated convolution, they are taking this formula 3 into 4 plus 1 for the receptive fields.
That is much more complicated position it is going. 7, it can have 7 by 7, 1 into 4 plus 3. What is that? 1 into 4. 1 into 4. 7 by 4 matrix only it is doing that convolution calculation.
Yeah. That's what they are mentioning, because that image is going to this size. 1, 2, 3, 4, 5, 6, 7, 7 by 7 size.
1, 2, 3, 4, 5, 6, 7. 3 by 3. My input is suppose 7 by 7 only there. That time convolution filter also going 7 by 7. Huh? Suppose input there actually input image is 7 by 7 and the kernel is 3 by 3. In case of two dilution, how the calculation I will do that? So
Can you go back to that question? Can you share it again?
yeah. Yeah. See, 1, 2, 3, 4, 5, 6, 7. Say here's also 7 by 7. My image is there, and kernel is 3 by 3. Two, three. But why first one he did not take? Oh, okay. First one is gap. That's why he started one gap. Okay. But why this is not taken? If here actually, if I see one gap taking two diluted row or column wise, both they are taking one by one gap. But in the last column they did not consider, right? 1, 2, 3, 4, 5. And what is this output size is coming? Say input size plus 2 into padding.
2 into 0 is padding.
Yeah, minus 3 is kernel size. Minus kernel size minus 2 into stride, maybe.
Stride should be divided by stride, right? In the
But
formula, it should be.
yeah, but one is what? Now nothing is left over. No, only one is stride is there. There is no, as per formula, whatever is given, that formula is not happening here. No, by stride is not there. Only here, this is the problem. 2 into 1 means here one what general one will be only stride plus a 1 again. That is what actually what is this calculation. Whether it is correct or wrong, who knows. Output here, output size equal to 3 is telling, but in your equation, whatever you are showing there, output how much is coming? 7 by 7 you are telling, no?
But these two images seems to be different. So
No,
the one which
but image size only if you take, see here telling that image size if whatever and kernel size this one, if I apply two diluted convolution, what will be the output size? That's the thing, no? So formula will be same. Forget about the value. I'm not talking later. We'll see. But formula wise here output size is 3 by 3 telling. But here how 3 by 3 output size? That's what it's not having formula. And
this
what?
formula I understood. They are telling means that 3 by 3 has become 5 by 5, and they are applying the formula. But how it became 5 by 5, I am not getting. This filter, it is 3 by 3. After applying two dilated convolution, it become 5 by 5 matrix. So this value will be correct, right? And in the image which is given in our PPT also, it has become 5 by 5. But any idea how it became 5 by 5 when it is 2D, two dilated convolution?
And this here it is telling output size will be 3 by 3. This is telling what?
Final output size will be 3 by 3.
How? I think it's clearing. Okay, just to get later you can discuss.
We'll check and confirm.
Yeah, this thing and one more thing is that I'm seeing
Excuse
actually.
me.
Pardon?
Excuse me. From ChatGPT, I got this formula. Can we try applying this one and checking if maybe it will help?
And if
I have shared in the Teams actually.
share
This
that.
one too.
Input, padding, and kernel size, everything is same. Can we try this one?
I input plus 2p minus d is what?
Dilation 2.
Dilation 2.
Minus d into kernel minus 1 minus 1 minus
Actually,
plus 1.
two dilation, the kernel becomes adding zeros in between here. Like
it will become 5 by 5.
Minus
I have
2
sent the screenshot to the chat.
It means skipping.
Yeah, minus 4 minus 3. Input equal to 7. 7 minus 3, 4 by 1 plus 1. Yeah, I think this is coming 5. Yeah? 1, 2, 3,
Can
4,
you share
5.
the screen?
Yeah, exactly.
22, 4.
Yeah. I think that formula is giving
No, the
output.
calculation part. Actually, calculation part. Something we have written.
Guys, can I present once?
Yeah.
Able to see the screen, right? Hello?
Yeah, I'm able
Yeah,
to.
yeah.
Okay. Let's suppose this is your input, right? And this is your filter here, all ones, right? 3 by 3 is the best case, I think. All ones. Now, if there is no dilation here, what will be the output if I apply the filter at the first point? All this, right? So it will be 1 plus 2, that is summation of all of this, right? That will be your answer.
Element-wise multiplication summation.
Element-wise multiple summation.
Sorry, this is your filter here, and this multiplied by this. So your answer, if the dilation is 1, right, will be equal to this multiply by this plus this multiply by this plus this multiply by this plus this multiply by this multiply by this plus this multiply by this plus this multiply by this guy plus this multiply by this guy plus this multiply by this guy. So this is the answer in case of dilation 1, right? This is well understood.
Yes.
In case of
Yes.
so similarly, I think you can just copy paste this. Can't. So in case of dilation 1, what will be the equivalent if you apply the filter at this particular point? This will take in this many pixels. Okay.
One more column G also.
Column G also.
Sorry.
It will take column G
Will
also,
take
right?
column G also, right?
Kernel what? The kernel will be this only, but we'll see which all pixels are picked up from this particular block. Right. So it will pick up in case of this is dilation 1. Dilation is equal to 1, 1. This is what we saw. This will be dilation 2, 2. Right. Now in this case, the same filter will be applied, but leaving away every alternate pixel because dilation is 2, right? So this will be applied as this into this guy. Leave the second pixel, I mean the consecutive pixel. Take the pixel after that. That is this into this guy plus. Now go to leave one pixel again and go to this guy. This multiply by this guy. Row wise also you have to skip alternate rows. right? So this was this guy plus this into this guy. Sorry, not this guy. This guy. Right. Plus again leave the pixel with value 2, go to the 1, right? Into
No, we are
No, we
skipping
are
the
skipping
entire
the
row.
entire row.
yeah.
Never.
Because
Okay.
dilation is I mean in both directions, 2 by 2, right? Vertical as well as horizontal direction,
Yeah, yeah.
Yeah, yeah.
Directly we are
Directly we are
right?
hitting column.
hitting columns.
Okay.
Okay.
What do
What do
question?
you question?
Plus this into, again I have skipped a row, right? And this guy, right? Plus this into this guy plus so this was the case, right? Okay, so answer is totally 9 it should be, right? Where did I do a boo-boo? So there are 9 pixels. Oh, I picked up this guy also somehow. 2 is, what color is that? F2. F4. G4. G. Yes. G.